Good morning, everyone. My name is Alexander D. Holloway, and this is Database Presto for ISA 4220, KSU Fall 2019. DBpresto. What is it? DBpresto stands for Database Presto. This is an SQL query engine that was made from the ground up as an open source analytical query engine. This type of engine was designed specifically to run large amounts of queries and data at super fast speeds. It supports multiple sources such as Amazon S3, MongoDB, Cassandra, and Hadoop distributed file system. These types of systems are known as non-relational sources. DBpresto can also support systems known as rational data sources, such as PostgreSQL, Amazon Redshift, Microsoft SQL Server, and MySQL. Some advantages of Presto are that it can query data where it is located instead of going through the process of moving it into a separate analytic system. So this means it can process local data that way. To get most results in seconds or less than seconds, Presto runs the query executions in parallel over a memory-based architecture. This is well known and widely used in all major applications that have a query-based system, such as Netflix, Airbnb, and Facebook. Back in 2008, Apache Hive was rolled out to help bring familiarity to the SQL syntax and to the Hadoop systems. It was originally started as a project by Facebook, which ran analytic queries against a 300 PB data warehouse. It was built with Hadoop HDFS based clusters. Before the Presto system, they used something called Apache Hive, which also had a huge impact on the Hadoop ecosystem because it helped with simplifying Java map reduce jobs with SQL-like queries. Back in 2012, Facebook came out with Presto, which operated much faster on a petabyte scale. In 2013, Facebook was able to release Presto to be an open source under the software license of Apache. Presto works by using something resembling an architecture like the classic MPP, or Massively Parallel Processing Database Management System. It is comprised of two components such as a coordinator and a worker. It is possible to configure multiple coordinators per cluster, and this is pretty common. For the first part, we will look at the coordinator. This component is made up of three parts: the planner, scheduler, and parser. Presto provides data location for the scheduler and metadata API for the parser, and provides a data stream for API for the API workers. This is done so as to be able to provide multiple queries for multiple data sources. A huge advantage of using Presto is that it can easily be plugged into other systems. Now there is something called the Hive connector that allows queries data that is stored in the HDFS to be mapped out with the Hive metastore. This supports all sorts of file types such as text, sequence file, AVRO, RC file, and ORC. Another advantage of Presto is being able to be pluggable. It can configure many Hadoop clusters into query forms. To simplify this, when using Presto for a query, a user will submit their SQL query, and then that goes to the coordinator, which uses an execution engine and creates a custom query to the parse, plan, and schedule a query plan that is distributed across the worker nodes. Some of the standard ANSI SQL semantics that it supports are complex queries, joins, left and right outer joins, aggregations, and window functions. And here are my references.